We are fast approaching a time when human intelligence will be incapable of fully comprehending the rapid pace of events in the physical world. The human mind is far too simple to handle the complexities of information needed to operate a highly technical and advanced global civilization. Self-erecting structures are but one inevitable result of the future direction of robotics, automation, and artificial intelligence. As these intelligent machines emerge from fixed positions in factories, they will be guided by satellites and directed to construction sites on land, in the sea, and in space. They will perform many of the functions of highly trained personnel with a speed and efficiency that is unimaginable today. They will construct our cities both on land and in the sea, dig canals, build bridges, operate factories and farms, transport passengers and freight, provide health care, and eventually be assigned the task of environmental and resource management. During this presentation, we will explore some visual concepts of the use of self-erecting structures within a global cybernated future as proposed by the Venus Project. Mega excavation machines are high-powered laser excavators of the future. Such a machine, directed by satellite, would be capable of fusing the earth beneath it into a molten, magma-like material, thus contouring the ground into canals, highways, waterways, and more. These concrete apartments are being produced as continuous extrusions, then separated. They are of high strength and lightweight. All the electronics would be an integral part of the dwelling. The outer shells of these efficient structures serve as photovoltaic generators. This surface uses the principle of thermoelectric modules, which convert solar radiation directly to electricity for heating, cooling, and other needs. Cranes, guided by GPS, transport and lift the prefabricated dwellings to site locations. This machine is a multi-function unit. It raises and inserts these extruded apartments into a support structure. These prefab units will allow individual selection in interior design and decor. Other massive cranes are designed to lift free-form structures and position them on foundations and stilts. Upon completion of their task, these cranes disassemble themselves into the most compact form and proceed to the next assignment. Tunnel segments can be floated by airbag and towed along canals to their construction site, where a catamaran crane elevates the units to their required position. For land assembly, this crane lifts the tunnels from the water and couples them together. Once completed, these tunnels can be used for high-speed maglev transportation. Catamaran cranes can also transport sections of a bridge and position them on their foundations. Once in place, these sections are able to rotate and interlock to form a complete bridge assembly. As artificial intelligence develops, machines will be assigned the tasks of complex decision-making. This would not imply a takeover by machines. Instead, it entails a gradual transfer of decision-making to machine intelligence as the next phase of social evolution. In the automated construction of larger bridges, the decks are gradually lowered by means of multiple cables on both sides of the tower to maintain balance. Once the decks are completely lowered, they are automatically and permanently coupled together. This enormous machine is positioning a transparent enclosure used for evaporative condensation. It places these enclosures over canals where they will serve as desalinization plants to supply clean water in arid regions. This is accomplished by harnessing the power of the sun, which evaporates the water and condenses on the cool inner surface of the enclosure. Canals and tributaries supporting these units will extend hundreds of miles into the dry lands. With this technology, we could supply much needed water for agriculture, fish farming, shipping, recreation, city needs and more, thus eliminating water shortages throughout the world. Applying technology in this way would enable a global society to achieve social advancement and worldwide reconstruction in the shortest possible time. Buildings can be erected by the slip-form method, whereby the outer walls are formed while concrete is pumped into the moving form. The concrete rapidly sets within as the form is continuously elevated. When the metal alloy nitinol is bent out of shape and heat or radiant energy is applied, it will return to its original form. In the distant future, the use of such memory material will allow all structures to self-erect, in a manner similar to the growth process of living systems. For example, a seed contains the genetic code necessary to allow its development into a full-grown redwood. In the construction of large domes, a mega machine travels around the structure, setting in place interlocking sections of the outer surface and forming a complete dome. Construction crews of the future consist of automated cranes that travel along the building's length, installing floors, windows, curtain walls, roofing, and other components from the ground up. Self-monitoring sensors will avoid industrial accidents. A high-powered laser excavator is tunneling its way through the bedrock. These machines can be designed to operate without any significant disruption of the environment. Eventually, robotic machines of the future will be capable of transforming their shape and function to accommodate any industrial task. Multi-access robots will utilize vast information resources, enabling them to receive additional commands by satellite while communicating with one another. They will also coordinate the logistics for each project. Eventually, factories will be designed by robots for robots. The cybernated systems would also be self-programming by means of environmental feedback. Machines will even be capable of self-replication and improvement of their operational range, while at the same time repairing themselves and updating their own circuitry. Since the computers and systems involved would be continuously self-monitoring, Parts could be supplied and installed well in advance of wear. Nanotechnology will be one of the most exciting fields of exploration. It combines the use of optics and lasers and will eventually enable us to assemble matter, atom by atom, into whatever molecular structure is needed. Nanotechnology, replication and cybernation will lead to a revolution in all fields, offering humanity the means to command its destiny to a degree never before attainable. If used responsibly, we could overcome scarcity once and for all, and virtually eliminate poverty and unnecessary human suffering, along with the need for repetitive and unrewarding work. We must understand that it is not automated technology or machines we should be wary of, but rather the abuse and misuse of technology by selfish interests. It remains solely our decision whether we use machines to elevate people everywhere or to serve our fears, prejudice, and power-seeking. Even our wildest and most imaginative visions of the future will fall far short of the technological potential of what humanity can accomplish once we have collectively declared all of the planet's resources as being the common heritage of all the world's people.